I have an equation sfxx is equal to 10 minus 5x square by 6 is equal to 0. Therefore 5x square by 6 is equal to 10 and x square is equal to 60 by 5, and we achieve the value of x is equal to 3.464 meter. So we achieve the value of x over here is 3.464 meter. So I wish it will be clear to you how this diagram has been plotted, that is specifically shear force diagram. Please see the figure over here. Shear force diagram, this variation is of parabolic nature, as we seen the equation of shear force variation along the length of the beam. Now next let us plot the bending moment diagram. We go over here. This is the given beam. With the load. These are the reactions known to us. Baseline, all the positive values above the baseline, negative values below the baseline. Also we know the distance, that is distance is of 3.464 meter. At this point we have the ordinate of bending moment is of maximum value. Now the first important rule that we have studied up till now, the value of bending moment at its joints, at its supports are 0 for a simply supported beam. So as for that, these values are 0. We know the maximum ordinate, we have to find out this ordinate. Before to find out this ordinate, and then we will join by any of the curve. Any of the curve means maybe a straight line, maybe a parabola, maybe a cubic parabola, or so on. So our intention is to find out how this BMD is varying along the length of the beam for this UVL. Let us take a section over here for the same case over here at distance x. We have already this diagram in case of shear force. This is of 10 kilonewton, and this ordinate that we have found out is 5x by 3, that we found out in case of while we have plotted the shear force diagram. Now our intention is to find out, this is distance is x, bending moment at xx is equal to, the first load is of 10 kilonewton, the perpendicular distance is x. So at this section, because of the load of 10, the bending moment is 10 into x. This creates clockwise moment, specifically section left clockwise. So if I will draw a figure, section left clockwise, this is treated as positive, this is the plus sign. Next load is of this UVL. So load is of half into x into 5x by 3. This is the total load, that is the area of triangle which is acting at the CG over here, and I want this distance, and that is nothing but x by 3. So into once again x by 3. So we achieve an equation 10x minus 5 x cube by 3 into 3 9, 9 into 2 18. So this equation you just visualize, this is the equation of x raised to cube. So we obtain cubic parabola as a variation while we plot the bending moment diagram. Hence we have to put the value of, in this equation, x is equal to 1, what is the ordinate, for 2 what is the ordinate, 3 what is the ordinate, 4 what is the ordinate, and up to so on up to 6 meter. Joining all the ordinates, we will achieve the variation of bending moment diagram along the length of the beam. Now let us put the value x is equal to 3.464 in this equation, and we will achieve bending moment maximum is equal to 10 into 3 into 464. Let's take another page. Bending moment maximum is equal to 10 into 3.464 minus 5 into 3.464 cube divided by 18, and we will achieve this value is of 23.09. So this ordinate is known to us, that is 23.09. Also you have to find out the value of bending moment at 1 meter. Find out by yourself. Find out the bending moment at 2 meter. Similarly, find out the bending moment at 3 meter. Find out the bending moment at 4 meter. Also find out the bending moment at 5 meter and bending moment at 6 meter. By finding out all the ordinates, you have to join these ordinates and you will achieve, you can visualize the given diagram of this kind, and this diagram is of nature of cubic parabola, and this is nothing but the bending moment diagram. So please visualize over here, the diagram is of cubic parabolic nature, and we will achieve the maximum bending moment at the location where the shear force is 0. So now we have achieved SFT and BMD in this particular problem. Let us revise, let us conclude certain parameters based on this particular problem. First, about the shear force diagram. First, as previously we know, the reaction at the simply supported beam itself gives us the value of shear force at that particular location. Second, for a simply supported beam subjected to the UVL, the variation of shear force diagram is given by parabola. Next observation for bending moment diagram, as we stated previous also, that value of bending moment at its supports for a simply supported beam are 0 at the supports. The variation of bending moment diagram is of cubic parabola for a simply supported beam subjected to the UVL. So now with this, let us go for the next problem. Now, problem next. Given beam is of simply supported beam subjected to a concentrated moment at the center. Just see the unit, kilonewton into meter, that is the concentrated moment acting at the CG. The given beam is of simply supported beam, so as we know our first step is to find out support reactions by our usual methods. So at A, given support is of hinge, the two unknown RAH and RAV horizontal reaction, vertical reaction, while at B, roller support, only one unknown, that is the vertical reaction RB. Step number 1, apply sigma H is equal to 0. We will achieve RAH is equal to 0 as there is no horizontal force which is acting on this particular beam. Let us apply sigma V is equal to 0. In the whole system of a beam, only two vertical forces are acting, RAV and RB. No external load which is acting on this particular system, hence RAV plus RB is equal to 0. Next, as in this equation, the two unknowns are there, RAV and RB, and obviously a concentrated moment is acting over here. So we have to take the third equilibrium condition, that is sigma m at any point is equal to 0. Let us take sigma ma is equal to 0. So the first is RAV into 0, so the moment because of RAV is 0. This 10 kN into meter, it is a concentrated moment which is of clockwise nature, so direct value plus 10. We do not have to multiply by any kind of distance because the concentrated moment is applying over here. Next load, that is of RB, creates a moment at A is of nature of anti-clockwise. So RB into the total distance is of 4. So minus RB into 4 is equal to 0. So we achieve RB is equal to 2.5 kilonewton. Visualize carefully, RB plus sign 2.5 kilonewton is there. Now let us put the value of, replace the value of RB as 2.5 in this equation, then we achieve RAV plus 2.5 is equal to 0. So we achieve RAV is equal to minus 2.5 kilonewton. What is the significance of minus sign? Minus sign indicated us that the assumed direction of RAV upward is wrong. We have to take it as a downward. Hence RAV is equal to 2.5, but specifically is of downward direction. So once these reactions are known to us, our next step is to go for shear force and bending moment diagram. As we take over here the same problem. The given beam is of simply supported, concentrated moment is of 10 kilonewton into meter acting at the center of beam. The reaction is of 2.5 kilonewton upward. This is of downward 2.5 kilonewton. Now let us recall step number 1. Shear force at A. This is my joint A is there. This is B is there. At A joint, the reaction is of downward direction, and as I stated earlier in the problems that for a simply supported beam, reaction at the support directly gives us the value of shear force at that particular point. So section left down 2.5, Down means it is of minus sign, negative nature. 2.5. As per this sign convention, section left down treated as negative. Now let us we start with our previous basic rules that we have studied in the previous problems. Between A and C there is no load. The variation of shear force diagram is given by horizontal straight line. So I will go for horizontal straight line because there is no load. At C there is a moment is acting. Once again repeat the word moment, concentrated moment. There is no effect of this moment for the plotting of shear force diagram. So once again between C and B there is no load. So between A and B there is not a single concentrated load is acting. I will repeat the word, concentrated moment is acting, but there is no concentrated load is acting between A and B. Hence the variation is given by horizontal straight line and then reaction RT. Negative sign. This is of my shear force diagram. I wish it is now clear to you. Next let us we go for bending moment diagram. Baseline. Support, the value of bending moment itself is 0. Between A and C there is no load. Recall the rule that we have studied in the previous 2 classes, that between 2 loads, if there is not a single load, then variation is given by inclined straight line. So we know the variation between A and C is of inclined straight line. Question about the magnitude. So if I will find out bending moment at C is equal to, on the just left of side of